Hi there, Mr. Sutton here, bringing you the Algebra 2 9-6 homework solutions on making inferences from experiments. For all the problems on this problem set here, we're going to be using this randomized comparative experiment that tests whether music therapy affects anxiety scores of high school students. So greater scores indicate greater anxiety. We have a control group with 8 students, and we have a treatment group which got the music therapy, and they also have 8 students. Here's the table with the results, and we're going to be kind of using this for the next few problems. So first part of this is they want us to find the experimental difference of the mean yield of the treatment group and the mean yield of the control group. So one thing I'm going to do to make my life a little easier is enter these two lists of members here into Desmos and work with it that way. So let me start by defining a variable in a list for my control group. So we'll say C equals, and then I need brackets to make a list. So I've got 49, 45, 43, 47, 46, 45, 47, and 46. And close that with a bracket. Now I'll do the same thing for my treatment group. So T equals, and then bracket, 39, 40, 39, 37, 41, 40, 42, 43, and just to double check, I should have 8 members on each list, and it says 8 element list, so that's a good check to see that I've got everybody. Okay, so I want the experimental difference here. I need to find the mean of my treatment group and the mean of my control group and subtract those, treatment minus control. Let me do the control first. So I'll do mean, parentheses, and C, that's where my control list was defined, and that comes out to 46. The mean of my treatment group was 40.125. So we have 46 and 40.1 if we round that off. So if I subtract those, that's going to come out to, I believe that should be negative 5.9, but you could run it in the calculator if you wanted. Next up, I'm going to do a double dot plot for this data. And again, I'll use Desmos for this. So going on there, I'm going to do a dot plot and parentheses, and I'll do it for my control group first. So I'll do C, and now I also have to put in kind of the interval length for my dot plot. Since I've got numbers that are going by ones, let me just do 1 for that. And now I have to go to my graph and see what this actually looks like. So let me minimize this so I can see my graph. Now I'm going to zoom out a bit so I can see it. Some of our earlier values are in the high 30s, so we're going to have to go quite a bit to the right here to actually see all that. And if we go far enough, then, oh, there we go. Alright, so my first list actually didn't have anything in the 30s. We started in the 40s. 43 was the smallest value, and then we had a few of these 45s, 46s, 47s, and a 49. So this actually looks like a normal curve almost. So here was my control sort of dot plot that I could see on Desmos. And now if I go back, and instead of using C, I just do T instead. And now it looks like everything has gone a little bit to the left here. So here's the dot plot using the treatment group. So just comparing these two things, we had a negative mean experimental difference between treatment and control, and we can see here on these dot plots that all of my data practically has shifted a pretty good distance to the left here from the control group. So based off of this, it's looking like this music therapy treatment might actually decrease anxiety scores. For this next problem, they want us to resample the data from exercise 1 and then come up with a new experimental mean difference between the new control and the treatment group. So basically you have to randomly reassign all of these and just do what you did in that part A from problem 1 again. So there's lots of different answers you're going to get because there's a lot of ways to randomly reassign things. I'll show you a quick way that you could do it on Desmos. Then I'll show you what I got when I did this the first time around, which probably won't be what I get when I show you just now. and you'll probably have your own answers, but this is a process you could follow. So going back to Desmos, and I don't need all this graphing room anymore. Let me get more room for my lists here and minimize this a little bit. There we go. All right. So at this point, I'm going to take these lists that I've got, and in order to shuffle them, the easiest way to do this, I think, is to first join them and then shuffle the joined list. And you can actually do this in one step. You're also going to want to give your new kind of joined shuffled list a name so you can easily pick things out of it. So I'm going to call that S. And S is going to equal, I'm going to shuffle a list that I get after joining my C and my T. So I'm going to do shuffle, parentheses, join, parentheses, and now I'm going to join C and T together. So C, comma, T. And I've got two sets of parentheses to close. And it's not showing the whole list here. It will if you want it to, though. This is the new list I've got after I joined these two lists and shuffled them. Now, in order to find the mean out of these, basically what I'm going to do is I'm going to find the mean of the first 8 elements. That'll be my control. Then I'll find the mean of the last 8 elements. That'll be my treatment group, and I'll just subtract those. So you could do mean of, and now if I want the last 8 elements, I can get that by writing the name of the list and then brackets to give me the elements that I want. So if I want the last 8, that means I need elements number 9 through 16. And the way you say 9 through 16 is with this dot, dot, dot here. So if I do that, I get the mean from the last 8 items. Let me subtract the mean from the first 8 items. So I'll do S bracket and then 1 dot, 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 8. That gives me the first 8. And that experimental difference, when I did it this time around, came out to like negative 2.125. Now when I did it the first time around, here was the new control group I got. Here was the new treatment group I got. And the mean experimental difference, I got a mean of 43 for that control and 43.1 for the treatment. That came out to, if I subtracted those, actually a positive number, 0.1. So just using this random reshuffling, it almost looks like anxiety scores went up with the music. But that just shows us that that negative experimental difference we saw with the original 2 groups actually meant something. We were not able to just randomly duplicate it by shuffling these students around. For this last one, they want us to analyze the hypothesis below, and we've also got a histogram that is the results of 200 resamplings of our data from example 1. So our hypothesis is that music therapy has no effect on the anxiety score. So we want to compare the experimental difference that we got in exercise 1, which I believe was negative 5.9, with all these resampling differences and see what we can conclude about this hypothesis. Does music therapy decrease anxiety? So if this is a true hypothesis and music therapy really makes no difference, then all of these random reshufflings, our score that we got of negative 5.9 in the first problem, should be kind of in the center of all this data. So how does it compare? Well, here is the center of the data. It's like roughly in this negative 1.25 to positive 0.75 range. The value that we got initially, the negative 5.9, that is way to the left of all of this stuff. Because it's so far to the left, it is unlikely we would just randomly get this by chance. There has to be something significant to the treatment. So this allows us to reject this Debbie Downer hypothesis that music therapy has no effect. And that means that we can conclude music therapy has a negative, which is to say a decreasing effect on student anxiety.